projections that go with those, and there are a lot of software out there, I guess, that have that functionality, but ESRI is somewhat more buried underneath different levels of toolboxes and desktop menus and so on. Recently, one of the instrument manufacturers for survey hardware, they decided in their wisdom to remove the functionality for surveyors to compute their own new datum shift parameters. A lot of guys I work with were rather shocked at that one. Some of you may have had the same experience. I guess there's a lot of scope for the ESRI product to incorporate that as a tool, or maybe for the Blue Marble guys to pick up on it. I know there's a lot of crossover between the third-party software and the ESRI software, so I don't want to talk about that, but it's definitely there. At the top of one of those lists of Kevin's earlier, there was a mention of spheroidal or ellipsoidal calculations. So the basic forward calculation on a spheroid comes into play a lot with long geophysical or seismic survey lines, and whether it's a ship sailing across an ocean, or we've got this great ability to transform and reproject on the fly, but where our source data sets have different coordinate systems, particularly where geographic coordinate systems, decimal degrees, are very popular in oil companies, we face this dramatic displacement effect where if you take a long line between two given points and geographical coordinates and display the line between those 2 points in the data frame in for example, a UTM projection, you're going to get a great distortion in the middle of that line. And we've always got these messages popping up on ArcMap telling us that you better be careful if you're trying to do edits or just display things in their correct relationships if they come from different coordinate systems. So what we don't have is something that will trigger us to automatically densify a long line, put some vertices in the middle, and it might not totally solve the problem, but if we densify a line, we may suddenly see it curved on our screen instead of a straight line, and relationship with other layers may be more correctly rendered on the screen. And then lastly, I work with a lot of geophysicists and geologists, and there's a lot of scope here and a lot of concepts to think about, but we exchange data in industry formats in the oil exploration industry, and some of the data we collect, like airborne gravity data or landborne gravity data, is not used to create geoid models and things like that. So there's a lot of scope there for maybe some format to be implemented, or some sort of consistent maybe mapping or something along those lines. And also crustal studies, which are mentioned by one or two other people. Not something I deal with directly, but they always are mentioned, and those kind of subjects are within the greater scheme of what Kevin has in mind. So I'll certainly watch with interest how this module may develop. Thank you.
Well, it seems to me that the impetus for this, from my point of view, has got to be satellite navigation, because if it wasn't for GPS becoming the predominant way of positioning, we wouldn't be talking about this, in my opinion. The reason I say that is because the satellites orbit around the center of mass of the Earth. They don't know where the Earth is. They have no interest in that. It's just that point. That's the origin. So therefore, the native coordinate system of GPS, GNSS, is Earth-centered, Earth-fixed, XYZ. Now, I was heartened when I talked to Kevin today, and you see it up here, right there under number 1, XYZ, and of course time, XYZ and T. Now, it's my opinion, and has been for some time, that we should be storing our data in XYZ and time. Now, when I say that, and I've said that, Patrick and I had a conversation at the APSG meeting, I've said that a lot, and the response is this, and it makes sense. I'm not saying it doesn't make sense, it does. We got a whole lot of archived legacy data and not know anything at all about XYZ because, of course, the satellite GPS is a relatively new development in Geodesy, and so therefore, what are you going to do, throw all that away? Absolutely not. Not suggesting that at all, never have been. Also, I want to say that I suggest that we store H, small h, not big H, ellipsoidal heights. Same thing. Fine, great, hooray, but we've got all this orthometric height stuff. What are we going to do with that? I'm not saying throw it away. We can have a discussion on this, and it could be an interesting discussion, but one of the things I really applaud is the concept of finally seeing that in a real module. I think it's a step that is huge. Now, Kevin has said he'll put it in a blob, and like I said, there's a lot to say. With that one step, I think we have moved from the 19th century. My goodness, it's been years I've been saying, why in the world are we using map projections on the computer? I can't figure out why we're doing it. The only justification I can think of is that that's the way we're used to, that's the way we've done it, that's the way our logical... Okay. I had a gentleman say to me just yesterday from oil and gas, how come GIS is 2D, or at the best 2.5D? I said, well, in fact, it's 3D, but you don't always see that. And I think that where Kevin is going with this is a real step. It's not just a new module, it's a real step in conception. And if it can be carried forward, I think this will become the predominant way of doing GIS. And that's what I got to say on it.
I just want to thank the panel very, very much for putting some thought into this and giving me and ESRI their ideas. I see that clearly nobody thinks that we should drop the idea but bring it forward, but make sure we do it right. And as I mentioned, all of these people I'll have dialogue with, ESRI and myself will have dialogue with as we move ahead, as well as many, many others. But I don't want to do all the talking. We still have time left, and I want to have input from the rest of you out there, asking anybody in the panel any questions, giving us comments, asking me questions, whatever. Is there anybody out there that would like to contribute? Oh, yes, there is a microphone for you. There you go.
Some of the panelists talked about time. Patrick talked about time. Jen was just talking about time, storage of what that time is. Jen just said very sure that we should store X, Y, Z, and T. Other folks say we should store the T not as a part of the coordinate, but as a part of the datum, or as a part of a temporal coordinate system. In the OGC, there's been some conversations about the concept of a temporal coordinate system. So I'd like to hear some ideas kicked around about where should the time go? Is the time part of the coordinate, or is time part of the system?
Well, I want to say, and very quickly, that IERS, as we all probably know in this room, is handling time in a real-time basis, and I think that's the way we ought to handle it too. And I would suggest that the ITRF system and especially its organization, the IERS, needs to be part of this module.
Yeah, I'd like